your topic is continuity, and here is an important question for you. So that fx equals to cos of x squared is a continuous function. So in order to solve this, just you should have the concept of composition of function, and then it should be known to you that composition of two continuous function is also continuous. One more important result should be known, that polynomial function is always continuous, and sine, cos, tan, these functions are always continuous wherever it is defined. So now let us solve this. Say the function is given to you equals to cos of x squared. Now do one thing. Here two functions we are observing. One is cos function, another is your polynomial function, or you can say algebraic function also, x squared. Now let us give separate name. Say gx is your cos x and hx is your x squared. Now see, sine, cos, tan, all these are continuous functions. We can prove it also wherever it is defined, because a sine cos function always continuous for all values of x. Then hx is what? Polynomial function. It is always continuous for all values of x. So g is continuous function, h is continuous function. We don't have any doubt about it. Now let us see what is the composition of g and h. This is g composition h of x, as by the definition it is g of hx equals to g of hx is what? H of x is your x squared. That will be your x squared. Now g function is defined in what way? G of something is cos of that. G of x is your cos of x. So it will be cos of x squared. Now you see, that is cos of x squared given for any x, g composition h of x equals to cos of x squared, which is nothing but your f of x. Now what you can say? That is f is equal to, by definition of equality of function, for any values of x, fx equals to g composition h of x, then you can say f is exactly equal to g composition h. It means f is composition of g and h. But g and h are what? Continuous function. No need to prove it. Simply from your textbook you can see it, that you can write cos function is always continuous, polynomial function is always continuous. As f is the composition of two continuous functions, so f is also continuous. So we proved it. Now similar questions, let us take from your textbook only. We are solving these questions, or it was your question number 31. In 32 similar question it is asked. So that fx equals to, let me write this. This time fx given as modulus of cos x. Modulus of cos x. You want to show that this function is continuous. So similar way you can approach it. Fx is what? Modulus of cos x. Do one thing. G of x, say it is your cos x, and h of x simply x. Sorry. It is your modulus function. One is modulus function, another is your cos function. So g of x equals to modulus of x, and let us take h of x this time equals to cos of x. Now you see, modulus function is continuous. You can, for any values of x, it is always continuous. So what we can do here, first of all, let us check h composition g. You check here h composition g of x. It is equals to h of gx equals to h of gx is your what? Modulus x. Then h of modulus x will be your hx is cos of modulus x. You may face this situation, that means this is not coming, then you this here, that will be g composition h. So now don't take this, simple g composition h of x equals to g of hx. G of hx is your cos x equals to and g function is defined as modulus function. So modulus of cos x, modulus of cos x. That modulus of cos x means what? Fx. So you can write f of x. So for any value of x, g composition h of x equals to f of x. It means what? F is equals to g composition h. Now simply you can give the logic, as g and h both are continuous and composition of two continuous function is also continuous, where f equals to g composition h. That's why f is also continuous function. Okay, now from your textbook, let us take the next question. Similar, this time given sine of modulus x. Fx equals to sine of modulus x is a continuous function. Then you consider it is as sine of modulus x. Then say gx is your sine x and hx equals to modulus x. As usual, g composition h you check. So g of hx, and this time what will come? That is hx is modulus x. So here you have to write modulus x. Now say g of x is sine x. The g of modulus x, sine of modulus x, that will be sine of modulus x, which is nothing but f of x. So again you can, for any value of x, g composition h equals to your f of x. So f must be equal to g composition h. It's the equality of function. By that definition we can write it. Now see, h is what function? Modulus function, and modulus function is always continuous, and g is sine function. As I told, it is also continuous. Composition of two continuous function is also continuous, and f equals to g composition h. That's why f is also continuous function. Now it is your in your textbook, it is your last question, 34, the old version. The edited version, a little bit changes are there, but okay, in 34 the question is given as the function f of x equals to modulus x minus modulus of x plus 1, and you are to find out points of discontinuity. Find out all the points of discontinuity for this function. First of all, you have to check the continuity at some points. How to select the points? You just consider modulus function as x minus a. Then modulus x I can think as x minus 0. So at x equals to 0, I will check the continuity. That means the possible point of discontinuity can be 0. And another modulus of x plus 1, I can take x minus 1 under modulus. So another point we will take, that is at x equals to negative 1. Means on the entire number line, because domain is set of real numbers in this case. Somewhere here it is suppose 0 and here it is negative. So these 2 points may be points of discontinuity we are going to check. And to the right side, it will be always continuous. To right side of 0. In between negative 1 and 0, it is always continuous. To the left side of negative 1, it is always continuous. So first of all, one by one, say at x equals to 0. So in this case, you find out left hand limit. Left hand limit equal to limit x tends to 0 negative. When we say x tends to 0 negative means value of x approaches to 0 from left side. So that is x is less than 0 in this case. When you will say x tends to 0 negative, x is less than 0. Okay, fx is what? Fx is modulus x minus modulus of x plus 1. Means we are going to find out left hand limit of this function fx. So directly I have written fx here. Now you see, limit x tends to 0 negative. Don't get confused about this symbol. 0 negative means just it's a representation that value of x is just smaller than 0. As x is less than 0, so from here you will get minus x. Minus. What about x plus 1? X is just less than 0. Then x plus 1 will be greater than 0. That means when we say x is your just less than 0, that means somewhere here the value of x, and you are reading plus 1, so it will go to the right side of 0. That's it, I think you know it. So x plus 1 greater than 0. When x tends to 0 negative, it means x value of x to the left side of 0, and if you add 0.005 also, then also it is greater than 0. Now see, minus of, it will be as it is x plus 1, it will be x plus 1, because x plus 1 is greater than 0, equal to limit x tends to 0 negative. Now what comes here? Minus x minus 1. Now if you take the limit, it will be what? Directly you can say it is negative 1. So left hand limit is your negative 1. Now calculate right hand limit. Right hand limit at the same point 0. That is your, if you calculate right hand limit x tends to 0 positive, f of x is your modulus x minus modulus of x plus 1, modulus of x plus 1, equal to limit x tends to 0 positive, and as x tends to 0 positive, it means x is greater than 0. As x is greater than 0, simply write x plus 1 also greater than 0, minus x minus 1 coming here. It is cancel of negative 1, so limit is negative 1. So one thing is your LHL, left-hand limit, is equal to RHL. Now what is f of 0? Functional value also you have to find out. F of 0 directly 0 minus 0 plus 1, it is also negative 1. It means LHL equal to RHL equal to f of 0. LHL equal to RHL, right hand limit, equal to f of 0. So f is continuous. F is continuous at x equals to 0. Next, another point is there, that is your at negative 1. Now let us check at the point negative 1 whether f is continuous or not. So see what happens at x equals to negative 1. As usual, left hand limit you find out. Limit x tends to negative 1 negative f of x equal to limit x tends to negative 1 negative. This negative means value of x to the left side of negative 1. Therefore, that representation we are using this symbol. Now you see, fx is what? Modulus x minus modulus of x plus 1 equal to limit x tends to negative 1, just negative sign. This sign we are using, that value of x is just less than negative 1. Now you see, x is less than negative 1, definitely less than 0. That's why what you will get? Minus x, and here also x plus 1. Most important, if x is just less than negative 1, and if you take the x plus 1 will be your what? And if you add x plus 1, then it is also less than 0. That means when x tends to 0 negative, then x plus 1 is also less than 0. That means value of x to the left side of negative 1. And if you add 1 also, then also it is less than 0. Now see, in that case it is less than 0, it is minus x minus 1 will come. Let me write proper way. It is your modulus of x plus 1 will be minus of x plus 1, then it will be plus x plus 1. X is cancel out, and the value will be just cancel out, 1 is left, so it will be 1. Left hand limit you obtained as 1. Now see right hand limit. Right hand limit is what? Limit x tends to negative 1 positive. So in that case, f of x is what? Equal to limit x tends to negative 1 positive. F of x is your modulus x minus modulus of x plus 1. Next you see, this equal to limit x tends to negative 1 and x tends to negative 1 positive. That means x tends to negative 1 from right side. So in that case, your x is less than 0. In either cases, whether x tends to negative 1 or x tends to positive 1, in either cases, x is less than 0, that is confirmed. So here also x is less than 0, then you will get minus x. Now what about x plus 1? but this time x is to the right side of negative 1. If you add plus 1, it will come to the right side of 0. That means x plus 1 greater than 0. So here it is minus x and plus 1, it will be minus 1 here. Because minus of modulus x plus 1 will be as it is x plus 1. Because of this negative sign, it will be negative. Now what you will get, you see. Here limit x tends to negative 1. Positive sign here from right side coming. So minus 2x minus 1. Now if you take the limit, if you put minus 1 here, that will be 2 minus 1, which is your 1. So left hand limit is 1, right hand limit is also 1. Next, functional value you have to check at the point negative 1. So f of negative 1 is what? Directly put negative 1 here, negative 1 under modulus minus modulus of negative 1 plus 1. It is cancelled out, this is also 1. So what do you obtain? LHL equal to RHL equal to f of negative 1 at the point negative 1. Means the function is continuous, f is continuous at x equals to negative 1. After that, you can confirm it that this function has no point of discontinuity. Possible points of discontinuity, these two where we have checked. And if these are continuous at these 2 points, it is 100% sure, that means there is no point of discontinuity. The answer is the function has no point of discontinuity. I hope this is clear to you. Thank you.